In this one, in the first part, we will keep m as a constant and prove that F is directly proportional to A. Mass as a constant and prove that force is directly proportional to acceleration. So the mass means mass of this cart, mass of this hanging, cart plus hanging mass. So for this part, we will be keeping a 50 gram. The value will be given in the data sheet. According to that, you have to do. So this is the hanging mass, 50 plus 5, right? 55 is the hanging mass. And the cart mass is 500 plus 20 plus 20. Okay? The cart mass is 540. This hanging mass is
540 grams, miss?
Yes. Hanging mass is 55 grams. So what is the force here? 55 by 1000 into 9.8. This is the gravitational force here. So in the first part, we will keep total mass as a constant. So total mass means 540 plus 55. 595 is the total mass. Throughout the experiment, we will not change this mass. Okay? And take one motion sensor. This one, yes. So we will be measuring the motion with the sensor. You know how to use this one. If you are using a cart, make it in the cart position, and the yellow should be on the first hall and black should be on the second hall. Okay. Then we will measure the acceleration with this one. In order to do the experiment, open the file. Uh, 102. Which experiment? Note and slow. When you are saving, this happens. All the readings are there. Don't save. So you can see a velocity time graph here. We are going to find out the acceleration. We will find out the acceleration and prove that it is proportional to force. Now the force is 55 divided by 1000 into 9.8. That is the force here. Okay. We will find out the acceleration. In order to keep this for prepare this for the experiment, make it in the cart position. 0 to 180, yellow in the first hole, black in the second hole. Open the file, you will get the graph. Okay. Then what you have to do is start the button, release it. When it reaches near this, before hitting, stop the system. You should be with the system. Let it hit, no problem. Just check it. When it is near to that black part, stop it. Okay. So start here. Let it move for some time. Stop here. Let it hit, no problem. So you will be cutting a linear graph there, right? Let us see. Okay. Let us see whether we are getting. When you are doing, no, when your hand is coming in between, you will not get exactly. So I am a right hander, so it is difficult for me here. If you are a left hander, it's okay. You can do like that. Right hander, this part will be okay. Then you can keep this in this side and do that. Okay. So, we are starting. Stop. Before hitting, you can stop. If it's small, you can make it big like this. Okay. I didn't stop before hitting. That's why this one. If you are cutting a graph like this, highlight this linear portion and take the linear feet. Then you got the acceleration 0.859. This is the acceleration when the force was 55 into 9.8
What is the
divided by
acceleration?
1000. Acceleration is that value. Now this is the first part. In the second part, we will take this 20 gram and keep it here so that the total mass is a constant, right? Total mass is 595 itself, and repeat it.
Doctor, here only in the first part only 20, right?
For 50 plus 20 plus 20, 540. Here 55. Now also total mass is 595. We took this 20 and keep it there. That means mass is a constant, but we changed the force. Force is increased as the mass increased. What is the mass here?
50.
No, 50.
55 plus 20.
55 plus 20. That is 75. 75 into 9.8 divided by 1000 is a force here. That means force increased. When force increases, the acceleration should increase. That is the experiment. Here also same process. Release, start the button. You will get a linear graph. Take the slope, linear feet. Then you will get the acceleration for this force. Okay. So as force increases, the value of this acceleration should increase.
3
lines you will get, 3 linear feet, 3 slopes in one graph. Take the print on one graph. Take the print. This is the first part of Newton law. Total mass constant, changing the force. Okay, you got it? Then according to your value, acceleration should be greater and greater when force is increased. Now, when you are doing, make sure that it's not touching anywhere. Okay, if it is touching, the value will change. If it's like this, it will touch. Make it on the upper portion while doing the experiment, then it will not touch here. Also, you can adjust this one for not touching. Okay, so this is the first part. Total mass as a constant, we change the force. In the second part, we will keep force as a constant. Okay, change the mass and find out mass is inversely proportional to the force. This is the second part. First part, total mass is a constant, change the force. Second part, force is a constant. So in this part, we will add 100 gram. The value will be given. Don't worry about that. So what is the total mass here? 105. 100 plus 5. So the total force is 105 divided by 1000 into 9.8. This part we will not change. Let it be a constant there. Okay. Here what we are changing? Mass. So here I think what was the value?
105.
Here
540.
no.
500.
It was 100 I think. You don't worry about this one. The value will be given in the exam. Okay.
For this one?
Yeah. Second part. So the mass is first 500 gram. The force. This is the first part. Same graph, velocity time graph, because we are finding out the acceleration. So this is the first part. Without any mass, force is 105 divided by 1000 into 9.8. Started, you will get the, please come here. Yeah, I'm starting, just release it. It hit, that's why it is like that. Otherwise, make the graph bigger. The linear portion you can take, highlight, take the fit, you will get the acceleration. Okay, here the force is a constant. So during the second run,
The slope is the acceleration for this graph?
yes, slope is the acceleration. Velocity time graph, slope is the acceleration. And in this part, we are not changing this force, so let it be a constant. We will change this mass, increase the mass. 100 plus, what is the 500? 500 plus 100, 600. Okay. Again, draw the graph. Experiment part is easy. Start, release, stop. You will get one more graph. Again, increase the weight. You will get another graph. Okay. This is the second part. So, as mass increases, acceleration should decrease because inversely proportional. This is the second part. It's very easy. In the first part, total mass as a constant, change the force. In the second part, force is a constant, change the mass. Okay, 3 lines in one graph. Okay, this is the Newton's law. Experiments are easy. Only thing is you will forget what you have to do. Now we will go to the friction part. We will be doing the second part of the friction in the exam. Okay. Can you take the friction things? Yes. So what was the second part of our friction experiment? What was the second part of our friction experiment?
No one will ask. No one.
That's why it's called revision.
Revision should be done by you only. Teaching.
It works on both sides.
So the second part of our friction was we were proving that static friction is greater than kinetic friction.
Yes.
Okay, Fs is greater than Fk. So this is our apparatus. You remember the apparatus? There is a force sensor. There is a tire button for.
Yeah, so we have to make it nicely.
We have to make it tire. After the quiz, you remember tire button.
Yeah.
Then this should be connected to which channel?
First channel.
Channel A. Channel A.
That's how I just in case.
والله حي.
Don't forget to switch on. So when you are doing, don't forget to make it loose, because otherwise the tension force will be also measured by the force sensor. We don't want that one. So make it loose, and we are putting some weight there. The weight will be given. Don't worry about that one. 100. Let me keep 100. This is friction. So open the file friction. Start there. You have the USB with you? Someone deleted some problem. File is not there. Okay, no problem. I will explain the experiment. You did the experiment, no? So, we are adding the mass which is given in the question paper. I added 200s. Okay? We are measuring both static and kinetic. That means without moving and with moving, we have to measure. Okay? Always remember, tear it nicely. It's very important. If you are doing, you are not getting the proper graph, means tear it, then repeat. Okay? So, this is the thing. We will do in the data studio this one. Channel A, everything is okay. Now the data studio. Friction should be in the data studio if it is not in the file.
Great experiment.
Yeah, great experiment. Done.
And it's the first
Channel
one.
Graph. Okay, channel A, force sensor. Okay, then the graph. In the second part, we are drawing only the graph. Second part only in the exam. Okay. We are drawing the graph connecting force and time. Tear it nicely. I told you we have to measure static and kinetic. So without moving, we have to open the system. Then only it will start measuring the friction without moving. Okay. Then start this. Let it wait for 2 seconds. It's measuring the static friction. Then start. Then you will get the maximum static friction. Then it will move. Okay. So I am starting. Okay, then start this. Then I can stop here. This is the graph you are expecting. Actually, the shape is not that much good. The graph will be like a peak and like this.
This
Okay.
is for the static friction.
This is the static friction. Or if you are getting like this, just make it big, zoom. Then you will get the static. This position is the maximum static friction. We have to measure the maximum static friction here. For that purpose, go to the smart tool, click it, drag this to this position, the peak. Okay. What is the static friction there?
1.4.
In the x-axis it is time. We don't want time. We want the y-axis value. 1.43 is the maximum static
But it's
friction.
negative, miss.
Negative. Why
Because it's a
negative?
trough
It's pulling.
It's pulling.
It's pulling.
or pulley.
Pulling.
That's all.
For the revision, don't ask such questions.
Yeah,
Oh,
okay.
stupid.
You did the experiment. So
How much
Fs
stupid
you
am I
got,
with you?
which is 1.43. This is the static friction, maximum static friction. We can calculate mu s, because mu s is equal to Fs by n. What is n? The normal force. How can you calculate the normal force? The total mass is here, right? Divide by 1000 into 9.8. That is the n. Fs we will get from the graph. We can calculate mu s. Okay. So we got mu s. Now we will go to, we will measure kinetic friction. Okay. So from this position, it is moving. So highlight this portion. Okay, highlight the moving portion. Then take the mean value. Yes, take the mean value and click all things and
Except for me, miss. So that's time because we forgot.
take the mean value. You will get the mean value here, 0.99. This is the kinetic friction value, Fk. Then we can calculate mu k, which is equal to Fk by n. N is equal to mg. Then we will prove that from these values, mu s is greater than mu k. This is the experiment, objective of the experiment. Okay, all these values we have to put, the weight, everything will be given. Don't worry about that one. Just do it, draw the graph, take Fk and Fs, find out mu s and mu k. Okay, so this is friction. First part of the friction will not be coming, only the second part. Then what is the next one? Hook's law. Today we did. Add more masses, force, extension, draw the graph.
It's only second part from only vertical.
Friction.
Only second part. First
So
part.
yeah, it will be only. You know how to draw? Listen here. For the force and extension, you should know how to draw the graph. That's all. You
Yeah.
know that, right? No need to show.
Only vertical.
Sorry?
Only vertical.
Only vertical will be coming because you didn't do the horizontal. It was just vertical, spring. Spring constant. You did it now. Yeah.
Only
We draw it
Yeah, you have to draw the graph.
by data studio.
Data studio. You know that.
Yes.
If data studio is not there, using pencil and scale also you can draw. If it is asked like that,
linear.
without data
It's
studio,
linear.
yeah, it should be linear. Without data studio, draw the graph. The question is like that. You can draw. You can take the values and draw like that. Force here, extension here. Find out the corresponding ones. And make it linear. Find out the slope value. That will be the constant. So next is simple pendulum. You know the simple pendulum, right?
Yeah.
Time period. Yeah. Most probably the stopwatch part will be coming. Stopwatch. You should know how to use the stopwatch. Start, stop, reset. There is a stopwatch there
Where?
on the table. There.
Yeah.
So you can check here. See, there is a start button. Okay. When it is moving, remember, excuse me. When it is moving, you are taking the oscillation, 10 oscillation, 5 oscillation, whatever it is given in the question paper. You have to measure.
1.35 seconds.
You have to measure the number of oscillations according to the question. If you are sitting here, please be quiet. My throat is pain. So, in the question paper, if it is given 5 oscillation, only 5 is enough. Okay. If it is not given, 10, 12, whatever it is given, take it that. So, oscillation, only thing you have to remember is, one complete oscillation means starting from one position, go there and come back. This is very
This is
important.
one oscillation.
Don't make it like that. Go there and come back is one full oscillation. Then let it move for some time. It's not that you're starting and hitting it. No, let it move. When it is starting, start. 1, 2, 3, like this you count. When it reaches,
Depends on the question itself.
when it reaches here, stop. Okay, then you will get the time. After getting that, reset, 0. Again, repeat it. Depending on the question paper, the number of oscillations. If you get time for 20 oscillations as 50 seconds, what will be the time period? 50 divided by 20, number of oscillations. Okay, you will get the time
This
period.
one's the difference between the small t and the big T.
Small t is the time, big T is the time period.
Time period. So it's
Okay,
different.
then you will get the time period. The question will be like, find out the acceleration due to gravity. You know the equation, or equation will be given. Don't worry about that. What is the equation?
2 pi
Yeah.
radical over G. L over G, yeah.
You have to find out
Mr.
G.
C, I remember.
You have to find out G. Okay. Changing the length. Repeat the experiment. And next is spring constant, Hooke's law. No need to show. You know it now, right? You did it now, so you remember.
خلاص.
Okay. So prepare for the exam nicely.
Yes.
Let's
This
finish
will
for
be
all
easy
of you.
exam, yes?
The question paper is not prepared by me. This time it's from Sajina.
Mr. Gina. So it will be hard.
Exam 1 was my